So, types of questions that you guys are going to see on your quiz. Okay, so the types of questions you will see. There's going to be a lot of those fraction type problems where they're going to give you something like this. Let's see. All right, so number one. So we'll do 2 over 3 minus 5 over x equals, we'll do 10 over x. Okay, so remember, this is the stuff we learned last week. Okay, Thursday, Friday. Thursday we did the easy ones, they called them, and then Friday we did the harder ones, and then yesterday we obviously did graphing ones, right? So the way you're supposed to do this is you're supposed to get all of your denominators. And again, you don't have to do it the way I do it. But I always used to list all my denominators and say, okay, let me take every variable and number that they give me and just kind of multiply them together. So I notice in terms of numbers, there's a 3. So I'm going to write it down. 3 to the first power, right? It's not 3 squared, not 3 cubed. It's just a 3. And then I notice there's an x there as well. X to the first power. So this right here, this is my LCD. That's what I'm going to multiply everything by. Okay, remember, the reason why we multiply everything by the LCD is to get rid of those fractions, right? We want to get rid of the fractions. So I'm going to write 3. Actually, let me change the color here since I usually use red for the main problem. So 3x times 2 over 3 minus 3x times 5 over x equals 3x times 10 over x. Remember, once you get rid of the fractions, the problem's supposed to get easier, right? If once you do this, it gets even more complicated, you know something went wrong, okay? Because it's supposed to get a lot easier. So here we go. Let's cancel stuff out. Look at the first fraction on the left side. What can I cancel from top to bottom? The 3, right? So the 3's gone. So that results in 2x minus, what can I cancel on the next one? An x. So there's an x there. So 3 times 5 is 15. What can I cancel on the last one? An x as well. So 3 times 10 is 30. Now your answers might come out as fractions. It might come out as normal numbers. I'm making up problems, so chances are I might get some weird fractions, but that's okay. Let's add 15. Right now we're just basically doing an algebra problem. No big deal. So that's 2x equals to 45. And my last step to solve for x is to do what? Yeah, divide by 2. And I get x equals to 45 over 2. Maybe if you put a calculator to do this, you'll get 22.5. But whichever one of those you want to use, that's fine. Remember, these are called the easier problems, okay? Where you have just a number or just a letter on the denominator, maybe a number with the letter in the denominator, but nothing more than that. No big expressions, no like x plus 3s or x squared minus 25s, nothing like that. Okay, so these are considered the easier ones. Now, just to kind of show you another one of these types of problems, but make it a little bit more complicated, but don't worry, it's not too bad. So number 2, we can try something like this. 1 over x equals 2 over, we'll do 4x plus x minus 2 over 4x. So we'll just do one more like this, and then we'll move on to what they consider the more advanced problems. So here we go. Let me put this up for you guys there. 1 over x equals 2 over 4x plus x minus 2 over 4x. Now remember, they could use x squared. Always, if they use a higher power, just remember when you're finding your LCD, you got to choose the highest power, right? So I wonder if I should do that here. I just don't know if it's going to turn out really bad. So I don't want to do it. I don't want to guess a problem. So we'll just kind of go with this. So here we go. I'm going to write down all my denominators. X, 4x, 4x. Now, you start with the numbers, right? So what different numbers do you see? Well, I see a 4. 4 to the first. It's not 4 squared, not 4 cubed. It's just a 4. So I'll take that. I know there's 2 of them, but you don't have to list both. Just list one. That's all you need. Okay? And then there's x's there, but none of them are higher than a power of 1. So 4x. This is my LCD. Okay? Now, I'm going to multiply everything by 4x so I can get rid of my fraction. So 4x times 1 over x equals 4x times 2 over 4x plus 4x times x minus 2 over 4x. Again, this is not a step you have to write down. At my age now, I don't even do that. I just kind of cancel in my head, right? But if you're still learning it or just feel more comfortable doing it, that's fine. If at your age you're like, oh yeah, I can do this without writing it down, that's okay. Do your pace, okay? No one says you have to do everything the way I teach it. Math is dynamic. It can be done many different ways. So here we go. What can I cancel in the first one? The x, so that's gone. That becomes 4 times 1. That's just 4. All right, what can I cancel on the next one? 4x, all of it. So all that's left over is a 2. What about the last fraction? 4x as well. So it's just an x minus 2. Now here you got to be a little careful, okay? Make sure that you distribute this positive into there just to make sure, because if it was a minus, it would change signs. So be careful with that, okay? Whenever you have binomials, always transfer that sign outside. This will be x minus 2. So 4 equals, 2 minus 2 is 0, so that's just x. So we're done. X equals 4. And that's it. All right, so this is the kind of stuff you're going to see. Now, if you want to see more examples, just so I can show you really quick, just go back to section 5.8 in Google Classroom, and there's a bunch of them right here, guys. Here's some with squares, right? V squared, V squared, V squared. Look at those. Okay, the notes are there for you. Don't forget that they're always there. If you're like, oh, I wish you would have shown us more examples, go back to the notes. There's probably 3 or 4 more right there. Okay, so anyway, let's go back to this review. So, any questions on these so far? Just what they would call the easier types. All right, so let's go to the advanced ones. So example number 3. So something more advanced might look something like this. And I'm making this up, so I really hope I don't mess this up. But let's keep our fingers crossed here. So that's x plus 5. Couldn't write that down. Now the reason why these are considered more advanced is because of the fact that you may have to factor. You may not, but you may have to factor. So let's write all of my denominators: x minus 5, x squared minus 25, and x plus 5. Okay, and for these, I'm going to see, do I have to factor them? So x minus 5, they don't have anything in common. It's a binomial. So I can't take out like a 5. I can't take out an x. So this one is just x minus 5. Okay. X squared minus 25. Anybody know what that's called? Notice it's a minus in the middle. We call that a difference. Yeah, it's a difference of 2 squares, right? It's x squared minus 5 squared, right? That's what this is. This is x squared minus 5 squared, which factors into x minus 5 times x plus 5. There's the factor for that one. Okay, and then the last one, I can't factor anything, so it's just going to be x plus 5. Now, what do? Well, I got to find my LCD. My LCD. So, this is what I'm concentrating on. Okay, this term here, these terms here, and this term here. Okay, I'm looking at those. So, let's start off with x minus 5. I see an x minus 5 there, so I'm going to put x minus 5. And the highest power on it is a first power. So, in other words, it's not like a x minus 5 squared or something like that, right? It's just x minus 5. Okay. I also see an x plus 5. So, I'm going to put it there. Also raised to the first power. Okay? So, good. We got everything we need because there's no number. There's nothing else there, right? There's no x plus 3 or x minus 2. That is my LCD. Okay? This right here is my LCD. X minus 5, x plus 5. Go ahead.
So the LCD is x squared minus 25 factor?
Yes. Yeah. That's what it turned out to be, exactly. So let me go ahead and do this. And the reason why we factor is because if I leave it x squared minus 25, then notice I won't be able to cancel anything in the first fraction or second because you're not going to see it. So I'd rather write it out factored. So here we go. X minus 5, x plus 5. This is my least favorite part of these problems because it takes forever to write them out. 2 over x minus 5 minus x minus 5, x plus 5 times. Now remember, if you look at my notes from when we did this section, when I write out the next step, I always write everything factored. So x squared minus 25, I don't want to just write that. I want to write x minus 5, x plus 5, okay? Instead of x squared minus 25. And that's equal to x minus 5, x plus 5 times 4 over x plus 5. All right, so first fraction, what can I cancel? The x minus 5 right here, that's gone. Okay, so let me just kind of rewrite it nicely here. That's 2 times x plus 5 minus, what can I cancel on the next one? All right, both of them, right? They're all gone, so that's just a 10 equals to, and the last one? Well, you're right. That's the result because I cancel out the x plus 5s, right? And yeah, that's going to be 4x minus 5. So from here, you just have to distribute a little bit and start solving, right? Again, that's just the basic algebra process now. So 2 times x, that's 2x plus 10 minus 10 equals 4x minus 20. Well, 10 minus 10 is 0, right? That's going to cancel, so I'm just going to kind of get rid of them. So 2x equals 4x minus 20. Normally, I would move the 2x to the right, but since I already have the negative 20 there, I'm just going to move the 4x to the left, okay? I usually like moving the smaller variable, but in our case, just it's not that big a deal. Negative 2x equals to negative 20. And if I divide both sides by a negative 2, I get x equals 10. These are called the more advanced problems, okay? Is the work different? Well, just in one aspect, you have to factor. In the other one, we never had to factor. Here, we do have to factor. So, yes, the work is different by that little bit, but the rest is the same. You multiply by the LCD, you cancel out, you simplify, and you solve. That's the same in the easy ones and the advanced ones. It's always identical. Okay, but yeah, there is that this portion up here, right, where you're going to have to look and say, okay, can I factor this, or is it good the way it is, right? And if you can factor it, then great, factor it. But if you can't, leave it alone. Then you got to choose your LCD. Once you do that, the rest of it is identical, right? All the stuff in purple, just multiply everything by the LCD, cancel out, and solve. That happens in the previous problems. It happens in this problem as well. Okay? So when you guys are kind of doing this, don't assume that the reason why we call them advanced is because the work gets insanely difficult. Not really. It's just factoring. Okay, I'm going to show you one more of this factoring type. Okay, so 4 over x squared minus 3x minus 4 equals 1 over x minus 4 plus 1 over x squared minus 3x minus 4. So again, one more of these advanced problems, then we'll talk about the stuff we did yesterday. Okay? Notice those denominators, the x squared minus 3x minus 4 comes out twice. Most likely, I'm going to be able to factor them. Okay? The x minus 4 on the bottom, I probably can't factor that. But yeah, most likely I can do the other ones. So let me write all my denominators here. I have minus 3x minus 4. I have x minus 4 and x squared minus 3x minus 4. I'll start with the easy one, the one in the middle. There's nothing I can do with that one. That's just x minus 4. Okay? The top one, which is the same as the bottom one, okay? Once I factor the top, then I just rewrite it for the bottom. So let's take the factor 4x squared minus 3x minus 4. I'm going to use the x method. Here's my a, b, and c. So a times c is negative 4. B is negative 3. What two numbers should I use? A negative 1, positive 4? Oh, negative 4, positive 1. Sorry, I didn't hear you guys. So negative 4, positive 1. Negative 4 times positive 1 is negative 4. Negative 4 plus 1 is negative 3, so that works perfectly. This is x minus 4, x plus 1. So let me write that here. X minus 4, x plus 1, x minus 4, x plus 1. So now I just got to write my LCD. Remember, this is what you're concentrating on, right? This stuff here, and this stuff here. You got to list every factor, right? Not multiple times, but like I see an x minus 4, so I'm going to write it down. X minus 4. The highest power I see on it is a first, so I'm good. I also see an x plus 1. I got a question from someone in my 5th period. They said, Mr. V, there's no x plus 1 right there. How do you list it, right? It doesn't matter if they all have it. It just matters that it exists. That's why you got to choose it, okay? So they don't all have to have that factor, just as long as it's there. Then you have to list it, okay? So that's my LCD. My LCD is that. So I'm going to multiply by x minus 4, x plus 1, okay? So let me go back to the original problem, way over here. And I'm going to put x minus 4, x plus 1 times 4 over x squared minus 3x minus 4 equals, so again, this is my least favorite part. Yeah, I like doing math, but sometimes I don't like doing the long writing portions of it. So this is, like I said, that's the part I don't like the most. So x minus 4, x plus 1, and then this is 1 over, oh, you know what I forgot to do? I just realized that. I'm supposed to write it factored out. I'm going to do the second one, but I forgot to do it on the first one. The first one I was supposed to factor it, and I didn't. So let me erase. It's just to make it easier for us to see what we can cancel. So there it is. That's the factored form. Okay, everything is factored out. So I'll give you a couple seconds to kind of do that. Like I said, this will be the last one of these factoring type, and then we'll move on to the ones with the horizontal, vertical asymptotes and the graphs of reciprocals and stuff like that we did yesterday. So what can I cancel on the first one? Everything, right? Yeah, everything's gone. So it's just 4 equals. What can I cancel on the next one? All right, so x minus 4 is gone. All that's left is 1 times x plus 1. So I'm just going to write x plus 1 because that's what 1 times x plus 1 would be. Plus, what can I cancel on the next one? All of it, right? It's all gone. This is all gone. So it's just a 1. Let me change this over. 4 equals x plus 2, right? And then just subtract your 2 and you're done. So minus 2. 2 is equal to x. All right, so that's our solution for that one. Again, you may have to factor, you may not. Okay, we did the first 2 problems, no factoring. We did the next 2 problems, factoring, right? So it just kind of depends on what's going on. Now, I'm just curious here. All right. So, question number 5. They're going to give you a function, okay? Let's say it looks something like this. And maybe the first thing is going to say, what is the horizontal asymptote? Now notice, yesterday when we did this lesson, there was nothing that you had to calculate, right? And I'm not going to expect you to do any of that in the quiz either. Everything should be something you can see. Okay, something that you can literally see right in front of your face. You just got to remember, where do I look for my horizontal asymptote? Okay? According to the definition, your horizontal asymptote is your k value. What is my k value? -2. So I'm going to write the following. This is the way you write it. Y equals -2. Why do we use y? Because any line that says y equals 2 is flat. It's horizontal. X equals creates verticals. X equals, okay? Y equals horizontal. X equals verticals. So they want horizontal, so y equals -2. What if I ask, now this is the one that's kind of tricky. What is the vertical asymptote? Now by definition, that's your h value. But remember, your h always shows you the opposite, right? So what's my h value? -1. It's not +1. That's what it's showing you. But it's the opposite all the time. So you're going to write x equals -1. Okay? Now, there's going to be, so there's some questions like that on the quiz. They're going to say, what's the horizontal? What's the vertical, right? Like it'll just be really quick. There's going to be some questions that are going to say this. Explain the transformation. In other words, how does it move? Actually, I guess it's not a question. How does this move? So the x plus 1 on the bottom and the -2 over at the end tells you that it's moving certain ways, right? So the x plus 1 tells me that it's moving one time in which direction? Up, down, left, or right? This part right here, let me highlight. That would be a left. A left once. Okay, and what about the -2? What does that tell me? A down twice, right? So, I just wanted to highlight because I'm not sure if you guys were seeing what I was looking at, so just to try to be obvious there. So you're going to say it goes left one time, down 2 times. So there are, I mean, I'm looking at some of them right now. Right here, question number 6. How is the function transformed from the parent function? In other words, how does it move? Right? Is it going up, down, left, right? How many times? Okay. So they're asking us those questions. I see one that says, what's the horizontal asymptotes? There's one where they're going to give you a picture and they're going to ask you to tell them what the equation is. So let me do that right now. Okay. So let me give you a picture. Are we okay with this one though? Horizontal, vertical asymptotes, and explain how it moves. All right. So here's question number 6. Now, I don't know if you guys want to draw this. It's completely up to you. Or you just want to let me do it and then you can look at the notes later on. So they're going to give you a picture. And then based on their picture, they're going to say, can you tell us which of the following would be, and it's going to be multiple choice, which one would be a good answer for something like this? Okay? But maybe what we'll do is we'll kind of just try to figure out what we have to write it out as. So here we go. Okay, and here's my graph. Yikes. And I'll try to give us like an ABC type of thing. So is it y equals 2 over x plus 1 plus 3? Actually, that should be a -3, sorry. B, is it y equals -1 over x plus 2 plus 3? Or is it C, y equals to -2 over x minus 2 plus 3? So let's take a look at this. In order to figure out which equation it is, you have to look at the point where those red lines cross, right? What's the point where these red lines cross right here? Like where they intersect. What would that point be? A -2, 3, right? H is -2. So how would it look like in an equation? +2. So let's see. Not that one. Not that one. The part B, right? It's not going to be A or C. Now let's just double check. The +3 on this equation means it should be 3 units higher than the x-axis, right? 3 units up. And if you look, it is 3 units higher. Now the negative is important because notice it has to flip the equation or the graph. So it did, right? Instead of being bottom left, top right, it's top left, bottom right. So your answer is going to be B. All right. So on your test or your quiz, they're going to give you pictures and they're going to say, okay, look at this picture. Which one of these is the correct answer? All right. So you don't have to draw anything. Remember I told you, you guys weren't going to have to draw anything specific. It's just looking and observing and picking the right information. Okay. So yeah, there's going to be a question like that. And I think that's it. Let me just double check. Let me pause it real quick.